Okay, so plan book has been updated. I don't have it here because, as we all know, we weren't here on Friday, but this would have been what we were going to discuss should we have been here on Friday. So go ahead and look at page 568. So these have been, these not fatty acids, these are carboxylic acids. We have not formed fatty acids yet. But what can you tell me about these three? Because we briefly discussed that last week. And if you didn't write them down, that's fine. You weren't asked to do so. But what is significant about perhaps the one in the middle? Why is it artificial? You're correct. Yes, because there's an odd number of carbons. It's got 19. Okay, this one's got 16, and oh my, 5, and then let's see here. That would be 12. So 17, 19. This one's got 20. Okay, so this one is found in nature. This one would be found in nature. This one's artificial. Okay. So on page 568, okay, the second paragraph down, we haven't talked a lot about melting and boiling points of compounds because it really was not, let's say, relevant. But in this case, where it begins talking about the melting point. This here, it is a little more important to know these physical characteristics. The melting points of fatty acids and lipids that contain them increases the number of carbon atoms, or number of carbons increases, and decreases as the number of double bonds increases. Okay, so the effect of the double bonds on melting point is large. Stearic acid is a saturated fatty acid. Okay, and has a melting point of 70 degrees. The melting point is lowered to 13 degrees, -5 and -11, with the presence of 1, 2, and 3 double bonds, respectively. So on your paper, it's got, if you back up a page, you were asked to mark the top 4 saturated fatty acids, lauric, mysteric, palmitic. No, that's not right. Lauric, myristic, palmitic, and stearic acids, be able to draw those. Okay, then the unsaturated fatty acids be able to match palmitoleic and oleic acids, as well as linoleic and linolenic acids. Okay, so with those physical properties, what can you tell me which one of these has the lowest melting point with what we just had read? What we see up on the board here. I don't even know which acid this is for sure. I think it might be linolenic, perhaps. Okay, so why would that be? I think you said it by, I'm not sure. Okay, so any compound that has a double bond or multiple double bonds, that is going to decrease its melting point, okay? Because from a long time ago, okay, we're really turning back the clock now, okay? And this is where this would make sense. Okay, this was a distinct organic family. It's an alkane. This is also a distinct organic family. It's an alkene. But which one of those reacts more easily? Why? Okay, and we said even something more specific. But you're not wrong when you say the double bonds. This has a specific name in there. Remember that? Yeah, weak pi bonds. So anytime you start increasing them weak pi bonds in there, for some reason, just the physical characteristic causes that's going to break easier, and therefore the melting point is much, much lower. Now, why would that be important? Well, if you ever leave butter out on the table, or margarine or something to that effect, you can do that, but it's eventually going to melt because a lot of butter probably is a polyunsaturated fat. So therefore, its melting point is really, really low because you can have multiple double bonds in there. Okay, so we wanted to establish these. Now, up here in the green, what has the highest to lowest melting point for myristic, linolenic, and oleic acids? So you want to start with the lowest or the highest? Okay, so of them, what has the highest melting point? I know that's right. I don't even have to hear you say the rest because why are you correct when you say this has the highest? Okay, because it doesn't have any what? Correct, okay? So this one is the highest. So if we're going from highest to lowest, it'd be myristitic, okay? Then of these two, which one's going to come next, oleic or linolenic? That is correct. Why? You looked in the book. Well, that's a good source. Okay, so then this one only has, like you said, one double bond. So then when we look at the last one, this would have the lowest melting point. And of linolenic or linolenic, which one will melt at a lower temperature? This one will. That's correct. Linolenic has one less set of double bonds in there, I believe. So when we classify these acids, saturated or unsaturated? Okay, this one is saturated. This one is, you sure? Yes, this one is unsaturated. And then this one is also unsaturated, but it's also what though? Poly. Okay, so why would we say this is polyunsaturated? Oh, just put that up there. Huh. Yeah, yep. Yeah, I know, that's funny. Maybe not. Yeah, it's a polyunsaturated fat. Okay, or acid, I should say. With a lot of what we take into our diet, it's probably going to be broke down to this compound, triglycerol, and then what happens is this goes through the process of esterification. And when it does that, that is when you form your assorted triglycerides, okay, or fatty acids. All right, so what we want to do then, okay, so create a triester or triglyceride from triglycerol, which is this, okay, with palmitic, lauric, and stearic acids, okay? So what do you think you would do first? Because from prior knowledge, what do you need to have to form an ester? An acid and an alcohol. That's right. Okay? So if this is going to be a triglyceride, well then it's no surprise you're going to have three acids to make your fatty acids or triglyceride. So we start with this molecule right here. Okay, so we'll just move him down here. I think that's, yep, that's still in view. Okay, then, let's see here. All three of these are ones that I believe you are responsible for knowing, but I wouldn't expect that you would know what they are by now. But what we should be able to do, okay, is when we line these up, we certainly know that we've got that molecule, and that molecule, because that's how all of these basically end, okay? Then, which one of these, we'll just start from the, we'll just go in order. So then, palmitic, okay, I believe, is that 14 carbons, maybe? Palmitic, okay, so 14 of them, okay. Okay, now, you probably have not seen them wrote like this before, because typically what you would do, okay, because typically when you write these from left to right, this is how they're conventionally written. But for our purposes, it's really important that we understand this concept. We're flipping this around, okay? You got to let me know if this doesn't make sense, okay? Like if you're doing carpentry work where maybe whatever board that's maybe 10, 12 feet long doesn't fit, so then rather than saying flip, which you can do, I can picture Mr. Ryan saying this, or anyone doing carpentry work, they say end per end it. So what does that possibly mean? You switch one end with the other, okay? So when we look at this, COOH, this is telling you what type of organic compound do we have. That is definitely an acid. So here is your COOH, okay? It's got these CH2 molecules, and there's 14 of them, okay? And then there's your methyl group. Does that make sense so far? You're just flipping the compound, okay? I mean, you could write this over here like it does in the book, but why might that not make sense to you? I'm not saying that it wouldn't, but why might that not make sense? Right, because you're not showing the removal of the water when you write it like that. Okay, so then if we're going to do lauric, I think that is 12, maybe? Nope, lauric is 10, okay. So therefore, so there's our COOH, okay. Okay. Now, whether you choose to put this bond in here, maybe, I don't know, that maybe doesn't make sense to you, but maybe keep it consistent. I guess, to me, that makes more sense to put it in there. If not, feel free to take it out, okay? Then stearic acid. Oh, oops. Yep. And then stearic acid is 18, is that right? 16. Okay. And go ahead and do that last one. This color. So now we've got this set up for making our fatty acid. So then what is our next step to finish this triglyceride? How do we get from this to a finished product that would be this triglyceride? And you've said it already, you just got to put it to motion. Okay, so we're going to dehydrate this. Okay, also from prior knowledge, which one of these OH groups totally disappears? Is it the alcohol side or the acid? It's the acid side. Okay, and then just as a quick review, if it was an ester, what gets named first, the alcohol side or the acid side? Yeah, because then it ends as ATE, the acid side. Okay, so then, okay, all of this gets stripped off. Maybe we should put that in there. Okay.
What were you doing when you said flip the side to the over on the right?
Okay, so typically, if you were going to write, this one is palmitic acid. When you look at that table on page 567, yes, what's on the left side is now on the right. That's what we mean by flip the sides. Okay, and then, so that comes off of your acids. This comes off of your alcohols. Okay, and then notice you still have your oxygens in here, and this bond is still there or present, because now that that has been dehydrated, we can, let's see, I need blue, purple, green, and black. Okay, so what are we going to write on this top line here? I suppose you could. I think that's how they illustrate that in the book. Oh, they just have one arrow. Okay. I'm thinking of what you see on page 571. I knew I saw multiple arrows in there. But regardless, okay, what are we going to write on this top line in blue? Okay, we need to finish this yet. Okay, then okay, let's go ahead and finish this then. I don't know if that's what you said.
No, I said hydrogen on the bottom.
But down here?
Yeah.
I don't think that's a hydrogen. Yeah, it's a bond between the carbons.
Oh, yeah.
Yep. Okay, so then what's left over in this top line then? Carbon. Okay. Then, okay. And CH3. Okay, so then you could say the same thing for the next one down. Only one hydrogen. There's our oxygen. Then transfer what you have left over, okay, which is this carbon. Okay, and then finally, the bottom one, link up our last carbon. Running out of room, sorry. Those of you who tune in later, I can put the blue away. Oops. And there is 16. So yes, that is going to take up quite a bit of space, as you can see. Now you formed a triglyceride. Not that this has a specific name. It just means you're taking these acids right here that may come from coconut oil, maybe it comes from corn oil, maybe it comes from peanut oil. Any one of these carboxylic acids may come from those different types of plant sources. Or are they animal sources? Could be, either one. Okay? Some from pork, fish, corn, soybeans, peanut. Okay. So then what you would actually be able to see then is on page 569. It's a different type of triglyceride, but example 19.2 is saying drawing the structures of triglyceride. So what you're doing is taking from your base structure, triglycerol, and then in this case it says draw the structure of the triglycerol containing equal molar amounts of mysteric, palmitic, and oleic acids. Okay, is that what? We didn't quite do the same thing, okay, but something quite similar. We had, instead of oleic acid, we put stearic acid in there. So what you see happening, same thing. Notice they flip-flop the sides, just like what we had done here. You dehydrate these in between here, and then go ahead and link them together. Now that's a lot to absorb in a short amount of time. So just be conscious of, just like you could say last chapter, you were responsible for those assorted amino acid structures. So if we're going to make a triglyceride, you would be responsible for knowing these three, and then there's one more, which is mysteric acid. Be able to draw that structure out. These also include unsaturated fats and polyunsaturated fats, but that's where the matching comes in. That would be wrote somewhere on your paper, oh, that is linolenic acid, so I know I can put that in here. You're not required to know that, you just need to be able to recognize it. Okay? We didn't, that took a little longer than what I thought. I see we're up to 22 minutes. So I would envision the rest of this week, we're probably going to do, we'll talk about the omega numbers tomorrow, because in my case, or maybe your grandparents, now I'm putting myself in the age of your grandparents perhaps, do they maybe take types of supplements? What would a supplement be? It could be vitamins, or in my case, I take fish oil, okay? So the oil means it could be some compound as complex as this because it's a triglyceride, okay? And we look on these bottles, it'll say omega-3 fatty acids. Because in my mind, and maybe those who take that, why would someone take fish oil as a supplement, do you think? You would think so, but no.
What?
I don't know if it really, that might be a reason to take it. And even in my case, maybe I take it because it just makes me think, it'll make me feel better that it's helping this process. For the ticker, what's the body's ticker? No, yeah, the heart. So yes, it's believed that omega-3 fatty acids are those types of compounds that will help with heart-healthy lifestyle, because sometimes what happens if you have a blood test, this also helps with what we call high-density lipids and low-density lipids. Which one do you think you want to have a higher number? The high-density lipids or the low-density lipids? You want more high-density lipids. And I can't really say for sure. This book addresses that, or the author does, but we'll talk about that at a later time. No. if maybe if you were thinking that, is that what maybe?
No, I'm just like, if a horse has a really bad cough, it's like an old racetrack trick.
Oh,
They
well,
dump fish over
anyway.
their throat and everything.
We'll catch up to you. Tune in next time, maybe.
Yeah, sorry
We'll
about that.
continue
Sorry
that
about that.
conversation. Yeah.